Time for day 2 here. We're going to be solving some equations with exponents. But first, I want to do a little bit more Bellwork, some problems like we had yesterday here. So some lovely Bellwork problems. Let's start with number 1 here. Remember, our goal here is to get a base and then have that exponent match the denominator of that fraction exponent, that rational exponent. So can I write 16 as something to the power of 4? Yes, I can. That would be 2 to the 4th power raised to the negative 3 over 4. I multiply that in, I distribute that in, right? My exponent rules are when I have a power to a power, I multiply the exponents. That'll give me 2 to the negative 3rd, which is 1 over 2 to the 3rd, which would be 1 over 8, 1/8, 1 divided by 8. Excellent. So far, so good. Here, I can't really, I don't have a common base there, but I could multiply these two exponents together. Let's see what that gives me. I'd have 49 to the, well, negative 1 times negative 3 is 3. 3 times 2 is 6. So that would be 49 to the 1/2. Now, we do remember that raising to the 1/2 is like taking the square root. But I could also, to go along with our theme of writing with an exponent that matches the base of that exponent, I could write 49 as 7 to the 2nd. And now these two exponents, when I multiply them, would just give me 1, 7 to the 1st, which equals 7. Bingo, bango. All right, this next one here says, write as a radical. And as we said before, in radical form, it's not as useful right now, but it's still a good skill to review. I know that this would be my index of the radical, right? The number that goes outside the radical. This is my exponent of the radicand. The stuff, the number or variables that are inside the radical. So I'm going to have the 5th root of 3y to the 2nd, or I can say 3 to the 2nd y to the 2nd, which would be the 5th root of 9y squared. 3 squared is 9. You dig? I dig. Let's keep it going. All right, I've got 2n to the 1/5 outside of the parentheses multiplied by the quantity and that wonderfulness in there. Well, what can I do here? Well, because this is out in front of the parentheses, this is not an exponent of the parentheses, I can distribute this into each term, right? Think about this. If I had a little sidebar action, if I had 2 parentheses x minus 3, I can distribute that in to get 2x minus 6. Got to make sure I distribute it. But if I had x minus 3 to the 2nd, I can't just do x squared plus 9. I have to think about this as x minus 3 times x minus 3, which would give me x squared minus 6x plus 9. I have to think about it as like foiling, okay? And that's a common mistake. A lot of us distribute that exponent in, thinking, all right, this is cool, not too bad. No, wrong. It's terrible. It's the worst thing you could possibly do in math, to just distribute it in. So don't do that. Got to foil. All right, back to your original scheduled programming. Let's do it. So when I distribute the 2n to the 1/5 in, I get 2n to the, and when I multiply like bases, I add my exponents. 1/5 plus 4/5 is 5/5, or just, I'll write it as 5/5. That's fun. It'll simplify to 1. We'll do that next. And then here I've got 2 times 5 is 10. And then I have n to the 1/5 and n to the negative 1/5. Well, that would be 0/5. 1 minus 1 is 0. So I have 2n to the 1st, which is 2n. And then that's n to the 0, so that becomes 1. And 10 times 1 would just be 10. There's my final answer for that one. Nice little warm-up, nice little Bellwork review of yesterday's stuff. It's always good to go back to it, right? We don't want to forget it. So now let's get to the new stuff for today, because I know you're just like, I am so excited. I want to solve with some exponents. Let's do it. All right, the key here in solving equations with exponents is get the same bases and set the exponents equal to each other. Let's do it in a very simple problem. I have 2 to the x equals 4. I can rewrite 4 as 2 to the 2nd power. So I'd have 2 to the x equals 2 to the 2nd. My bases are both 2 and 2. So if my bases are equal, it would make sense that my exponents would need to be equal. So I'm going to set those two exponents equal to each other. X equals 2. I'm done. We'll obviously have some more complicated problems. There might be a sum or a difference in the exponents. Oh, it's gonna be cray, as they say. But there's our basic strategy here. Like bases, set the exponents equal. Let's keep going. We have ourselves a plethora of examples here. One of my favorite words. It means a lot of. Okay. There's actually a famous movie. Are all movies famous? I'm not sure. With some fantastic comedians that use the word plethora in it. If you know it, let me know, and I'll give you either an Air 5 or a Virtual 5 or whatever it is. It's going to be fantastic, though. If you do know who or what movie I'm talking about with the plethora being used in there. All right, moving on. So the first one, I already have like basis. That's fantastic. New color. So I can just set my exponents of 2x and 12 equal to each other to get x equals 6. Done. All right, next one. I'm going to go below. So we have 9 to the x and 3 to the 5th. Well, 9 can be written as 3 squared, 3 to the 5th. I always like to start with writing that part in parentheses as its own thing. And now I'm going to deal with the exponent rules. Power to a power, you multiply. So I have 3 raised to the 2x equals 3 to the 5th. Now I have like bases. I can set the exponents equal to each other. 2x equals 5. So I get x equals 5 over 2, or 2.5. Done. Okay? Again, I like to write in parentheses what the equivalent of 9 is with a base of 3, then deal with my exponents. Otherwise, I feel like it's easy to make a mistake. Maybe that's just me. No, not just me. Many people. Okay. Orange time. Can I write 8, 2, 4, all with a common base? 2 would be my common base. So I'm going to have 2 to the 3rd to the x equals, well, that's already good. And then 4 would be 2 to the 2nd to the 9th. All right. Now, let's apply some exponent properties. I'm going to have 2 raised to the 3x. Then I will have 2 to the 7th. And then I'd have 2 times 9 would be 18. 2 to the 18th. Gonna need some more room. Now, what do I do when I'm multiplying like bases? I add my exponents. Always go back to those rules, right? In the cabeza, those 5 rules. Multiplying like bases, I add exponents. So now I have 2 raised to the 3x equals 2 to the 18 plus 7 is 25. 25? I do believe so. All righty. So I'm going to set my exponents equal to each other, which would be 3x equals 25. I have like bases. I can set the exponents equal. Divide by 3. That's not going to simplify, so I will leave it as 25 divided by 3. And we are done with that one. Uno más. Uno más. Purple. So I have 9 to the 1, or x plus 1 equals the square root of 27. Okay. First off, I think I'm going to write this as 27 raised to the 1/2. Let's change it to exponential form, right? We can go either way with those. I can change exponential to radical, radical to exponential. This is going to be more advantageous in our solving of this problem. Now, 9 and 27, can those be written with like bases? Yes. 3 would be my base. So I'm going to have 3 squared to the x plus 1. And I'm going to have 3 to the 3rd to the 1/2. Just to the 1/2. Sorry, that sounded like I was going to say more. We'll continue on. Sorry about the lines there, guys. So my exponent rules tell me to multiply when it's power to a power. So it's going to be 3 raised to the 2x plus 2. So I got to distribute the 2 to the x and to the 1. Equals, and then here I'm going to have 3 to the, well, 3 times 1/2 is 3 over 2. Ugh, fractions, right? You can handle them. You can handle them. It's going to be great. I got like bases. I can set my exponents equal to each other. So I've got 2x plus 2. Don't forget to distribute that 2. Let me tell you what, that happens to some people. Be careful. Equals 3 over 2. All right. Wonderful. So what I'm going to do here is 3 over 2. I'm going to subtract 2. So I'll have 2x equals 3 over 2 minus 2. Let's see here. I would have minus 4 over 2 if I get a common denominator. And now I'll have 2x equals negative 1/2. Divide by 2. That's like multiplying by 1/2. We're going to end up getting x equals negative 1/4. Lovely. A nice little fraction. How fun is that? How fun is that? So fun. Wonderful. I mean, you can even check these things back in there if you'd like. I'm going to keep on moving here, but you can always plug back in to see if it works in the original problem. All right, some things to watch out for here, right? We don't want to steer you wrong. We want to let you know where some of these pitfalls might be. So we got to get a single base, b, first before we drop the bases and set the exponents equal. So here I have 2 to the x equals 2 to the 5th multiplied by 2 to the 2x. I can't just drop everything right now, and because what operation would go between the 5 and the 2x then? Well, let's first address this with our exponent properties, right? Let's go back to our 5 basic rules. I would have 2 to the x is equal to, and what do I do with my exponents when I have like bases? Like bases, I add my exponents. So I could have 2 to the 5 plus 2x. Now I have a single base on each side. I can drop those. I can get x equals 5 plus 2x. Let's see here. I'll go ahead and subtract 2x. I get negative x equals 5. So x is going to equal negative 5 in this one. Lovely. Lovely. All right. Let's keep moving. How about, this looks like a lovely color. So when I have, that was end of a period. So when I have division, what do I do with my exponents? Well, I would subtract, right? Division with like bases means I subtract my exponents. Well, let's do that so we can get the left-hand side into 1 common base. So we had 2 to the x squared minus 4 equals 2 raised to the x. Exponent rules, subtract when you have like bases and you're dividing, or when you're dividing with like bases. That's a better way of saying that. Well, now I have 2 as my base, 2 as my base, right? A single base on each side. I can set x squared minus 4 equal to x. And I'll have x squared minus x minus 4 equals 0. Woo! Woo! What do we have here? Factoring, my fave. X, let's see here. Can we even factor that? Yeah, we can't even factor this one. You know what? I'm going to make a brief change. I'm going to make an executive decision. We're going to change this to 3x. That was an awesome 3. Again, that's not the best. And then, so that'll make this 3x, which would make this one 3x, and then I'd have a negative 3x. Sorry, the music started playing there in the passing period. Gotta max out every moment of our day here to get these wonderful videos to you. Alrighty, so what multiplies to negative 4 and adds to negative 3? That'd be negative 4 and positive 1. I didn't feel like dealing with the quadratic formula, and since I'm the teacher right now, I have the power to change things. That's a teacher flex? I don't know. All right, so I'm going to get x equals 4 and x equals negative 1. I would work in this situation because I would have, if I plugged it back in, if I plugged 4 in, I would have 16 minus 4, because my exponent rules, it's 12. And if I plugged 4 in, I'd get 3 times 4 is 12. And if I plug negative 1 in, I'd get 1 and 4. I would subtract those exponents to get negative 3. And if I plug negative 1 in here, I'd get negative 3 as well. You can see that they work out. They both work out. All righty. So it's important to remember those rules. When we're multiplying like bases, we add the exponents. When we're dividing like bases, we subtract the exponents. It's often confusing, and you're like, oh, I'll just divide or I'll just multiply them. Got to pay attention to those 5 basic rules. It's definitely a place where people make mistakes. I have a feeling this is a possible place for mistakes, hence the giant stop sign. Let's take a look here. What we're saying is that this is not the same as getting common exponents. If I have x minus 2 squared equals 10 squared, just because my exponents are 2 and 2 doesn't mean I can just do x minus 2 equals 10. What will actually happen is we'll be missing a solution. For example, over here, 3 squared is equal to negative 3 squared. Perhaps this would be a little bit more aesthetically pleasing. However, 3 is not equal to negative 3. You see the disconnect there? See what it doesn't make sense. So what we're going to do is we are going to take the square root of both sides to solve. And I'm going to be left with x minus 2 is equal to plus or minus 10. All right. We didn't necessarily have to write this. You could have just taken the square root of 100 and get 10. But we do have to have the plus or minus 10, because if this number in here is 10, once we do x minus 2 is 10, squared is going to give me 100. And if I get this quantity to be negative 10, squaring it will also, right, raising to the power of 2 will also give me a positive 100. So now I have x minus 2 equals 10, x minus 2 equals negative 10. So I get x equals 12 and x equals negative 8. Wonderful. There's my two solutions. Had we done what we said before, like if I did x minus 2 is equal to 10, like drop my exponents, as you can see, that is what we have right here, except for we would have been missing this one off to the right-hand side, right? So we don't want to be missing a solution. That's why we cannot do that. All righty. That was awesome. That was fun. So be careful on those things. We can get into this like groove of like, oh, like bases, drop the exponents. Like bases, set the exponents equal. Like bases, set the exponents equal. I'll do like exponents, set the bases equal. Nope. Okay, we get into this groove. You might make a mistake, so be very careful. That was a slight voice crack. We're moving on. Last one here. We'll do a little bit of group work or some practice problems, something like that. So here I have x plus 1 to the negative second. Let's see here. Couldn't I write that as 1 divided by x plus 1 to the positive second? And then either I could write that as 5 to the second, or what we might be seeing here is that I'm going to take the square root. All right, I'm going to square root both sides, take the square root of both sides, and I will have 1 over x plus 1 is equal to plus or minus 5, right? When I take the square root, I have to do a plus or minus when I'm solving, due to what we talked about before. So now I'm going to set up two separate equations. I will have 1 divided by x plus 1 equals 5. And then in another color, we'll do 1 divided by x plus 1 equals negative 5. So I'll work with the green one first. I'm going to go ahead and multiply by x plus 1 on both sides. So I'll have 1 equals 5 times x plus 1. I got to distribute that 5. Subtract, I get negative 4 equals 5x divided by 5. This is great stuff. So negative 4 fifths. And then in the light blue, not the lightest blue though, we could go even lighter, but I don't think that would be very helpful. Once again, I'll multiply by x plus 1, and I'll be left with negative 5 times x plus 1, the quantity x plus 1. Distribute my negative 5. Add 5 this time to get 6 equals negative 5x. Divide by negative 5, and I get x is equal to negative 6 fifths. 6 fifths. Woo! Negative 6 fifths. I like it. Fantastic. Wonderful. Thank you guys for joining in here, and I hope you enjoyed it as much as I did. Okay? Have a wonderful day. Good luck on the practice problems, the homework. America Freedom, rock and roll, Costco. Make sure you're following Riverdog Jenny on the gram if you don't already. And I'm going to keep doing more hand gestures, and then I'm going to stop the video.